HVAC temperature rise formula for measuring airflow CFM reveals how many cubic feet per minute your system actually moves and directly predicts comfort and moisture control. Learn how to interpret CFM per ton for precise humidity and cooling balance. Use the temperature rise formula. CFM equals 344 times the tonnage times the temperature drop across the coil divided by the sensible heat factor when necessary. But for practical field use, the simpler form, CFM, equals total heat load in British thermal units per hour, divided by 1.08 times the temperature difference in degrees Fahrenheit, gives a direct read on other time, airflow. Measure return and supply temperatures with a calibrated probe at steady-state operation after the system has run at least 15 minutes. Averaging 3 readings across the grill to remove local stratification. Calculate tons by dividing sensible load by 12,000 British thermal units per hour so you can express results as CFM per ton, where industry target ranges are typically 400 to 600 CFM per ton for most residential systems. Lower values around 300 to 350 CFM per ton increase dehumidification but can cause coil freeze risk if evaporator temperature drops too far. Higher values near 600 and above reduce dehumidification and boost sensible cooling, potentially leaving relative humidity too high for comfort. Adjust blower speed using the motor tab or variable speed settings while monitoring static pressure with a manometer to keep total external static pressure within the air handler manufacturer's recommended range to avoid reduced coil. Performance and increased fan power. If static pressure exceeds recommendations, inspect and clean the coil and filter, check duct leaks and undersized return paths, and correct register balancing. When interpreting CFM results against comfort and humidity control, always cross-reference supply dewpoint and return dewpoint to assess latent removal and use a psychrometric chart mentally. If supply air enthalpy is low but humidity stays high, reduce CFM per ton or add dedicated dehumidification. Finally, document every change and retest conditions at the same outdoor and indoor load conditions to validate the tweak, rather than relying on single measurements. One of the top 3 common mistakes is using single-point temperature readings for airflow measurement, which skews CFM calculations and leads to improper balancing. Fix by averaging multiple probes across the grill and waiting for steady-state run. Another frequent issue is ignoring static pressure and duct leakage when CFM is low, causing poor dehumidification and comfort. Repair leaks, enlarge return paths, and match fan curve to system requirements. The third mistake is applying a one-size-fits-all target CFM per ton without considering humid climate impacts and sensible heat ratios, resulting in high relative humidity or overcooling. Correct by calculating sensible heat ratio, then adjust blower speed or add a dehumidifier to hit comfort goals. BigHomeProjects.com lists vetted local HVAC contractors and detailed service profiles related to airflow testing and dehumidification, so homeowners can find technicians who understand CFM per ton trade-offs. The directory also helps contractors get work by showcasing proven expertise, customer reviews, and job types they handle to match the right pros with each project need.